Hey guys, here to give you a screencast on an explanation of what we call orbital filling diagrams or orbital diagrams. And basically an orbital diagram is simply sort of a pictorial way to represent an electron configuration where we had written numbers for those electrons. We actually use arrows. And one of the kind of cool things about electrons is that when you have two electrons that are close to each other, they actually do, in essence, not exactly, sort of spin in a direction. And one of those electrons is going to go clockwise and the other one is going to go counterclockwise. And so we represent those two different, what we call spins, with an arrow that goes up and an arrow that goes down. And so one of the rules is that when you have electrons in orbitals, you're going to fill one electron in each orbital for a subshell before you come back and then fill the other spin. Right? So you're going to separate the electrons as much as you can. That makes sense, right? You're going to put as much distance in between them as you can. And then if it's not, possible, like, and you need more electrons in there, then you're going to come back and put multiple ones in orbitals, but they're going to have the opposite spin. So the trick orbital filling diagrams is simply to draw a box that represents one orbital. And so for an s orbital type, you will have one box. For p orbitals, you have three boxes. They're connected. D orbitals, you would have five. And again, F orbitals, which we won't be doing in this class, would have 7 boxes. And you write them either, sometimes you're going to put them in a line or sometimes like in a horizontal line like this, or you could write them, I'm going to skip like this, where you have all the S's in a column, and then the P's are a little bit to the right in a column, and then D's a little bit further to the right in a column, and F's would be even over. And then on the vertical axis would be the order in which they would fill. Right, so those are two different ways to write orbital filling diagrams. All right, we're going to just go with this, and then you can see how all these boxes are labeled. And so we know that lithium has 3 total electrons. The first 2 would be in this first orbital, 1s. So I have 1 electron going up and the second electron going down. And then the last electron that lithium has is a little bit further out in a spherical orbital. That is, it's called the 2s. And so we're going to fill those up arrows first. Now, as I continue across the periodic table, elements 3 through 11, you can see that now the 4th electron here, I can put 1 more in this s orbital, so I'm going to put that here for beryllium. Element boron has 5, so I'm going to add on that 2p sort of box of 3, and it only has 1 in there that I'm going up. Now, this is the trick. Carbon, you can see, has 2 in that 2p, but I don't put them in one box. I spread the electrons out as much as I can. So I put 1 electron here and 1 electron here. You can see that nitrogen has 3 in the 2p, and I've spread them out completely as much as I can. Now, if I come back nitrogen after nitrogen is oxygen, it has 4 there, then I would have another electron in, another electron in this one, right? And then fluorine would have 1 more in there. And then you can see that neon, element number 10, they're completely full, right? And so now when I've completely filled up, that's when I put the next electrons in another orbital. And so I'm only going to draw the orbital shapes or the boxes that I need. And that's it, pretty much. That's how you do it.